grab the microphone.
Can everyone hear me? Is that any better? What about now? Okay, cool. So this is just a very brief presentation on dynamic VPNs and basically how to fake doing a DMVPN type solution. Might have turned on my clicker. Okay, so just quick introduction. I'm Welby McRoberts. I'm a principal engineer at Rackspace. Unfortunately, Rackspace doesn't use MikroTik products. Wish I could change that, but Cisco, yay. I've been a Router-OS user since about 2009, and my background's actually nothing to do with networking, so I feel a little bit odd being up here, but operating systems and applications are basically my thing. So I'm sure for most people in the room, they're going to know what a VPN is, but I'm going to give a very brief sort of crash course in what VPNs actually are. So as a general rule of thumb, they are a private link between either a client and a site. So that would be, for instance, if I was using my laptop to connect back to head office or something, or a site to site. So that might be if you've got two branches that need to connect or something along those lines. You've got a plethora of protocols that you can use. Some of them are SSTP, L2TP, IPsec itself, OpenVPN, so on and so forth. And despite the name, you don't actually need to be doing encryption. However, I think in the modern world, anybody not doing encryption on a link is probably going to be having fun at some point. So when you're designing a VPN, you've got to take into account actually what do I need to connect to everything. So as a general rule, for a headquarters connecting to a branch, you're going to use a simple site-to-site link. You can go down the road of having multiple branches connecting to a central site. Generally, that's going to be what's referred to as a star topology. So just on here, we've got a very simple example. So obviously, just two sites connecting here. That's just a simple site-to-site VPN. Nothing particularly crazy there. And then at the bottom, there's another example here where we've got multiple different sites connecting back to London, because apparently that's the center of the world. So complex VPN design. Basically, the more connections that you're going to have in a VPN, the more you're going to want to tear your own face off, because it gets bad. If you're talking on a simple one, where it's I say simple, a simple complex one, where you've got multiple headquarters or branches connecting, you're still going to have a major amount of management overhead to worry about. It can mean that simply if you've got a single change needing done to, let's say it's an IPsec and it's an encryption domain that you're needing to change, if you're changing that at the headquarters, depending on what firewall you're using, that can potentially mean that all of your VPNs disconnect and you're going to have to reconfigure them at the other end. One of the ones that's most fun with this is Checkpoint. If anybody's had displeasure of working with that, and VPN summarization, I think they call it. Yeah. Another thing that you've got to worry about is your bandwidth availability at the headquarters. So if you're doing multiple headquarters connecting to each other and you've also got multiple branches connecting there, how do you ensure that you have enough bandwidth to actually allow those branch offices to access either things in other branches or stuff that's actually in the headquarters itself? One way that people get around this is either a partial or a full mesh VPN. Plain IPsec on this is an absolute nightmare. So for one of my customers that I look after, we have, if memory serves me right, it's 73 separate VPN tunnels between each of their, well, between all the environments. And when the customer comes and goes, where's this IP address? Since they've got overlapping network ranges, it's a nightmare, basically. It does, however, mean that you don't have to worry about your bandwidth issues, because Site 1 connects to Site 2 and 3 and 5 and 29 and so on and so forth. As I've said up on here, though, you can lose your sanity on it. So this is an example of a multi-hub and spoke. So this would have been the sort of first one that we had up there. So you can see that we've got Chicago and London as two HQs. The American offices are all connecting to Chicago. The European and, well, actually, sorry, the rest of the world offices are connecting to London. And then there's presumably a high enough bandwidth link between Chicago and London. So if anything's needing to go from New York to Sydney, it should hopefully be fine. And then the fun one comes on with the full mesh. I had to be really careful when drawing this because I was frightened that I was going to be summoning a Cisco salesperson by drawing that, but luckily that didn't happen, so we're all good. So how can you do a mesh VPN without losing your sanity? So multiple different vendors, as usual, have different ways of doing it. So Cisco's the big player in this space, just purely because, well, nobody's ever got fired for buying Cisco. Not quite sure why, but hey. DMVPN is their option. So this is basically a multi-point GRE tunnel. So it's a thing called a non-broadcast multiple access tunnel. So this basically means that you've got one tunnel configuration on the device, and then another device, you just also configure it with one tunnel, and it can figure out everyone else within the mesh. I've put on here that it's an easy config. To be fair, it's pretty humdrum in terms of the way that configuration would be done. It does, however, unfortunately use a proprietary protocol, something called NHRP, which is the next host resolution protocol, if I remember correctly, which basically means that unless you're on a Cisco device or someone who's reverse engineered that protocol, you're SOL. You're not going to be able to use DMVPN. For distributing routes, it does, however, still use something moderately standard, so OSPF is usually the way that people would deploy it. Juniper do actually have their own version, GetVPN. It is I can't remember if it's an ITF standard or if it's just an RFC. In theory, it's supported by Cisco. Good luck getting them to talk to each other correctly. There are so many caveats on connecting the Junipers to the Ciscos that it's almost not worth doing. The way that most larger enterprises will end up doing this is that they just go, screw it, we're going to do MPLS because then I don't have to worry about it. I farm that off to a service provider. Router OS. How do we do DMVPN? You don't. That's the simple one there. There's no NHRP support. There are a couple of ports for Linux. They don't really work particularly well, unfortunately. To my knowledge, there's no GetVPN support. That leaves us in a little bit of a sticky situation. If you've got loads of MikroTik devices, how are you going to do a dynamic VPN? Well, we've got all the prereqs. We've got all the prerequisites for that. We've got GRE, which works on not just the MikroTik devices, but basically on every platform. We've got IPsec, yet again, same thing, works on most platforms. And then you've got your dynamic routing as well that you're able to use. Sorry, excuse me. Let's try that again. Could be worse. I could be having the fire alarm go off. Sorry, Ron. Okay, so as I said, you can choose your different routing protocols there. MikroTik luckily supports just about everything. So how can we achieve this? Scripting. It's the best tool that we have in our arsenal within RouterOS. It really does leave your option open. However, if you've come from an operating system perspective, it is horrifically limited. It would be wonderful to have some more common languages available, Perl, Python, Ruby, whatever we want to talk about. I know in version 4 we had Lua for about 2 beta releases and then it disappeared. I'm presuming there's security reasons for that, but it would be great to have something on the router. Even if it's being able to just actually interpret something like JSON, that's going to be a huge improvement to what we've got at the moment. As I'll mention later on, string manipulation in RouterOS it's difficult. So you're probably asking, why the hell is there some operating system guy up here talking about this? So as a general rule of thumb, operating system folk think that networking is some black art, and everyone that does it is effectively a wizard. There's no two ways about this. I'm sure the same is true for the reverse, where why have we got all these weird operating system folks? The biggest problem that we've got at the moment is because companies are trying to save as much money as they can, we're going down the route of software-defined networking, which is a little bit of a buzzword for anyone who's not in the cloud space at the moment. But if you're in public cloud, you are using SDN, and you are basically having to plan for that for the future. So this is why you're going to see a lot more operating system people starting getting into the networking space, and then networking folks getting into the operating system space. Another thing here is that, frankly, I find labs to be one of the most boring things in the world. I want to go and try things in the real world. So I started doing this because, well, we've got a load of operating system network folks at the place that I work. Why can't we just do this from home? It's a large number of people. A lot of people are using either MikroTik or Linux or FreeBSD devices. We can make a complex network that is effectively a live network. We've already got complex things like overlapping networks, so it might be that 3 people are using 192.168.0.0 or whatever there. And also, this reduces anxiety around the subject. So if I go, for instance, to a normal support team in any service provider, you're going to find that the support guys, as soon as you start talking networks, they go, whoa, we're going to need to get someone special in, we're going to need to go through 20 years of change board and so on and so forth. With the reducing anxiety, to quote someone, do it live. We might, we've found that with doing these sorts of things, there's actually a couple of my colleagues here today, we found that actually they've started to be more comfortable with networking, and it actually works really well. And on the networking side, it's increased the OS knowledge. So how have we actually done it? So as I say, there's a group of about 10 to 15 of us. Most of us are using router-OS. Majority started with a 751 or a 951. A couple of people have come late to the game and gone 3011s immediately. There's some people using Linux or FreeBSD. There's a couple of them that just aren't willing to let control go of their operating system. They want everything down to the last detail to be controlled. Which is fine, So we've set up this thing called the VPN, which is obviously a really unique and original name for a VPN. It's effectively just a certification authority. We're using IPsec, we're using GRE, we're using BGP, and for the majority of the people, they're using a router-OS script. How's that actually working? So basically what we've got is a central server which manages all of the IP addresses, all of the individual users, the routers, all that sort of jazz. Running on the cloud, because yay, cloud, we've got to do the cloud, haven't we? So user signs up for an account, gets approved by an existing member. Once that user's been approved, they'll log back in, add in a router. They give it basically the DNS, because effectively no home ISP really gives a static IP anymore, which is a shame. We've then got, basically they also choose a router type as well. At the moment, we only provide things for router-OS, but if somebody wants to go and write their own little script to do it for FreeBSD, Linux, whatever they want, that's fine. They get provided with an API key, which is just basically used to make sure that the router is identifiable. They get provided with the router's AS number, the CA certificate, and also the router's certificate and key. Now, the reason that they're getting provided with that over a public means is that basically there is no standard way reliably of doing certificate generation on multiple different router types and then it actually working without having to go down the SECP route, and that is just a whole can of worms I don't want to get into. Once that's all done, the user's obviously going to need to set up the router. We've provided instructions for people how to do that. And then they can go and request a routable IP range. Effectively, what's happening is that range is assigned to an individual AS, but to the user, it looks like they're assigning it to a router because we've a one-to-one mapping of routers to ASs. So we got the router script itself. Basically, it's moderately simple. Does make your eyes bleed when you look at it, but it is moderately simple. Basically, make sure that we've got a load of sort of global configs. So that's going to be things like the BGP instance that we use for this. Whilst it's very unlikely that anybody's going to be running BGP at home, we just thought we probably want to separate things out into a separate instance just in case. Route filters are created. At the moment, these are really simple, but the idea will be that effectively, since we've got an individual IP range per AS, set it so we can do some funky things with filters. So set it that, let's say, for instance, I can only announce, I can only be the AS announcing my own ranges. Obviously, they can come through me, but not have it so someone else can announce my range, for example. We also create an interface list, which at the moment is not used, but will be used for doing firewalling at a later stage. Basically, the script will then go and get the peers from the web app. As I said, string manipulation is nice and fun. So what we are effectively doing is sending a string, which is name, and then a pipe, DNS pipe, protocol pipe, all these. Putting a comma at the end, and then just keep doing them until we've got no more. Turning that into an array, and then splitting out on the pipe, which is not great, but hey, it works. What we then do is we go and we create a individual GRE interface and the appropriate IPsec peer and policy. Goes, removes any old tunnels, and also the appropriate peer and policy there. Puts any tunnels that are in existence into that interface list, creates any new BGP peers, and then removes the unneeded peers from there. What issues have we had? Don't trust anyone. Doesn't matter how good they are at things, they will mess up. We had at one point, without those route filters, somebody decided it would be hilarious to go and put in the default route into the table. I'm sure anyone who's worked in any sort of larger networking capacity is probably laughing, going, why the hell haven't you put a route filter in? We get that now. Dynamic DNS, as I've said, basically home ISPs mostly don't give static IPs. I think PlusNet's probably the only one left in the UK now that does. You could argue that Virgin are static, because I think in 3 years I've had one IP, but they're not officially. Other issues that we've got is, for some reason, UK and the US are terrible at providing upstream bandwidth for end users. I think the majority of people are on sub 10 megabit worth of upstream, which is a bit of a pain. We don't really have any way at the moment of steering traffic around bad upstreams, really. And then the other one is latency. I mentioned Virgin Media. If you've ever seen a Virgin Media connection that doesn't have latency, please tell me how the hell that's been done, because it's basically like this all day, every day. The jitter on them is impossible to work with. So some of the things that we're looking at improving in it, multiple uplinks. So there's a couple of the people, I think 2, have got multiple home providers. At the moment, we don't do anything with that. It's a case of, well, there's just 2 of you, we'll look at that another time. That's something that we're going to look at improving. In a business sort of environment, this might be that your ISP can't provide you a way of increasing your actual bandwidth. So you might have ISP1 and ISP2, and you want to distribute the traffic over those 2. How do we do that? I've mentioned here manipulating the AS path on latency. So a couple of ideas that we're sort of floating between us and the other folks on there, mainly the networking guys, have come up with a sort of few ideas on basically padding out the AS path if we've got high latency on the line. We haven't figured out how to do that yet, but that's something that we can be doing. Other protocols, scripts for other devices, the firewall rules, as I've mentioned, Looking Glass. Hey, if you guys want to suggest anything, go nuts. You know, this is all open for people to sort of to use. So, can you use this? Absolutely. It's all open source, MIT license, so basically do what you like with it. The only thing that is not there at the moment is the web application, because frankly I've written it and it was horrid. So I'm rewriting that now, and that will be on there within the next month or so. It's all on GitHub. Isn't great being able to say word Git in a polite place. The only thing that we would say is that if you are going to use this commercially, we can't stop you. It's open source. You're allowed to do whatever you like with it. However, we'd ask that if you are using it commercially, just donate to one of the charities. It's things like Doctors Without Borders and things like that. It doesn't matter how much, just the token thing. Yeah. And also the most important bit, if you are going to be using it, please, any changes, feature requests, improvements, just put them on the GitHub. That's basically the presentation. I do have the copy of the script on here if anybody does want to see it, but if there's any questions. No one? Oh, sorry, yes. MTU issues, they're all set at, I think it's 1400. So basically, as a general rule, if I remember correctly, 1418 is the correct one for anyone over PPOE, but I could be completely wrong there. But basically, we've said, what's the lowest that we can reasonably do? 1400 sounds great. Anyone else? Nope. Oh. So there's no support that I'm aware of interpreting JSON within router OS. It could be. I'd have to write a parser to do that, and I'll show you in the code. Programming is not my specialty, but I did want to cry when I when I started doing string manipulation. I'm used to, when in my sort of day job, I'm used to using things like Python or even TCL for the likes of F5 devices, which is a big jump up from what we've got on here. I'll show you in a few moments the what I'm talking about in the script. I'll just see if there's anyone else. No? Okay, cool. Let me bring up the script. So, no, I need to make that a bit bigger. Hopefully everyone can see that now. People at the back, all good? Bit bigger, okay. That any better? Okay, cool. So basically, as I said, when somebody gets a script, they have a load of variables that they have to change. These aren't actually used at the moment. That's for if we ever go down the route of using anything that's going to end up using radius. I know that I think it's in 6.38 in the current beta, there's now support for XAuth with using radius or IPsec, so that might be something that we also end up using. There's various things like the router ID, so the IP address, so on and so forth. There's a load of checks basically making sure that the end user hasn't been silly and forget to change anything, effectively just erroring out and stopping if things haven't been changed. Creates the individual configurations as we were talking about, and I'm just going to scroll past this to get to the string side of things, which is frankly absolutely disgusting and horrid, and I hope that I never have to write anything like that again, where it's effectively going and saying, take 0 as being the start, find where the next pipe is, and then extract the name as being 0 to wherever that pipe is, and then keeps going through that all the way down to the last, basically the last thing. Puts it into an array, and then we can iterate over that in a little bit of a nicer way. Which I think might answer the why there's no JSON there, because from my perspective, absolutely that would be ideal. Cool. If anybody's got any other questions, that's cool. Otherwise, I'll hand over to the next person. Excellent.